Okay, let's dive into this. Welcome to today's explainer. You know, it's pretty wild, but some of the world's absolute most complex AI runs on code that honestly reads almost like plain English. So if you've ever felt completely intimidated by those giant walls of cryptic symbols, well, you're in exactly the right place. Today, we're handing you a conceptual coding starter kit. We're going to take a real builder's journey to demystify Python from absolute scratch.
Here is our concept to creation journey for today. First, why learn Python? Then, setting up your environment, followed by variables and data types. After that, we'll hit operators and control flow, organizing data with lists, and finally, the fun part, building rock, paper, scissors. All right, let's get moving.
Section 1. Why learn Python? The power of Python. As Dave Gray notes in the source material we're looking at today, Python is a great first or additional programming language to learn. So think of this explainer as your personal hype man. Whether you are starting totally fresh or you're just adding a brand new tool to your belt, you can absolutely do this. So why is Python so highly recommended in the first place? Well, for one, it's got a beautifully simple, straightforward syntax. It literally reads incredibly close to plain English. It's also wildly versatile. People use it for everything from web dev to hardcore data analysis. Plus, it boasts this massive, super active community, which makes it absolutely fantastic for rapid prototyping. And, maybe most importantly for a lot of you, it has a massive footprint in the job market right now.
Moving on to Section 2, setting up your environment. Let's build our workshop.
We can actually break this workshop setup down into 3 super rapid steps. Step 1, you just download and install Python directly from python.org. Step 2, install Visual Studio Code, or VS Code. It's a total industry standard, so it's going to be your ultimate workbench. And finally, Step 3, add the official Python extension right inside VS Code. That is going to give you auto-formatting and color coding, which, trust me, makes your life infinitely easier.
Okay, once your environment is all set up, you unlock this thing called the REPL. That stands for Read, Evaluate, Print, Loop. Basically, by opening your terminal and typing Py or Python 3, you drop into this interactive prompt. You can literally use it like a calculator to instantly test out your code, line by line. It's a perfect little sandbox.
Section 3. Variables and data types. These are our raw materials.
Now, there's a really vital distinction we need to make right off the bat. Expressions versus statements. An expression actually evaluates to a value. Like if you ask the REPL 2 plus 2, it spits out 4. Simple, right? A statement, on the other hand, performs an operation. Think of variables like labeled storage boxes. When we type name equals Dave, we are using a statement to drop the text Dave into a box that we've labeled name. From then on, Python knows exactly what's inside that box.
So what actually goes into those boxes? Different data types. A really fundamental one is the Boolean. It represents pure logic. Think of it acting just like a simple light switch that holds only one of 2 states, true or false. And hey, here's a crucial quirk you gotta remember. Python strictly polices capitalization. That means a capital T for true and a capital F for false. No exceptions. We're gonna rely on these heavily for our game logic later on.
Building out the rest of our raw materials, we have strings, which is just text data wrapped up in quotes. Integers are your solid, whole numbers. Floats, those handle your numbers with decimals. And of course, the Booleans we just talked about. What's really fantastic here is that Python allows you to dynamically cast or convert between these. Like, you can turn the integer 100 into text just by wrapping it in a string function. Pretty cool, right?
All right, Section 4, operators and control flow, the logic and the plumbing.
So, control flow is basically how your code moves step by step in a serial direction. Imagine a waterfall navigating around a bunch of rocks. It flows top-down, and it branches off based on whatever obstacles it hits. But I gotta give you a gentle warning here. Python is a notorious perfectionist when it comes to whitespace. If your indentations don't line up absolutely perfectly, well, the waterfall crashes and you'll get an error.
To actually direct that flow, we use operators. The assignment operator, which is just a single equal sign, puts a value in a box. We use arithmetic operators for doing math, and comparison operators, like the double equal sign, to check if 2 things are completely identical. Then we use Boolean logic, words like and, or, and not, to route the water. So, if X is true and Y is true, the waterfall flows left. Otherwise, it flows right.
Section 5, organizing data with lists. Think of these as our storage crates.
To solve the whole data organization problem, we use lists. Think of lists as these large storage crates holding multiple items in a very specific sequence. Crucially though, Python counts starting from 0, so your very first item actually sits at index 0. Using built-in methods, we can manipulate these crates effortlessly. .append throws an item right at the end. .insert slides one into a specific spot. .pop pulls out the final item, and .clear, well, that dumps the crate completely.
And finally, Section 6, Building Rock, Paper, Scissors. It's time for the final build.
Okay, we've got our blueprints, we've got our tools, and we've got our logic. Now for the main event, how does Python actually decide who wins rock, paper, scissors? Like, how do we tie a user's typed input to our control flow to actually determine the outcome of the game?
Well, we just break it down into 3 steps. Step 1, we use the input function to ask the player for a 1, 2, or 3. Step 2, the computer picks its own random number using a module called random.choice. Step 3, we send both of those choices right down our waterfall using if, elif, and else statements. Does x beat y? Boom, player wins. Elif, which just means else if. Does y beat x? Computer wins. We cascade down this logic, making sure we catch every single possible win, loss, or tie.
But there's one final bit of polish we need. If the game spits out, you chose 1 and the computer chose 3, that's kind of confusing, right? Enter enums, or enumerations. Instead of using these awkward, what we call magic numbers, we assign human-friendly constant labels. So 1 becomes rock in all caps. When the game finishes, it translates those raw numbers back into these labels, telling the user exactly what happened in plain, readable English.
And literally just like that, you've built a fully functional game from scratch. Code is really just logic, flow, and raw materials organized well. You now understand variables, control flow, and lists. The blueprints are officially in your hands, and honestly, coding is the closest thing we have to a modern superpower. So the only question left for you is, what world will you build next?